Okay, we're going to talk now about configurational isomers. We've already talked about one type of configurational isomers. Basically, these are the types of isomers where you have to break a bond and rearrange the atoms in order to go from one isomer to the other. And the one that we've talked about is the cis-trans isomerism. We did that under alkenes. And we just want to continue on a little bit with two other possible types, and that's the EZ. That's not standing for easy, but EZ is a nomenclature thing, and optical isomers. The EZ isomerism is similar to cis-trans isomerism, but cis-trans you only have the two branches that you really have to worry about where they're going. But what if there's three? What if there's more than just the two? So this is what we have to take care of in terms of our nomenclature. So rule number one, you would look at the atoms directly attached to the carbons involved in both ends of the double bond, attach numbers corresponding to their mass, okay, thus ranking them in terms of their priority. So if you have them on the same side, if we look at the notes on page 316, if you have them on the same side of the double bond, then you would designate that as Z or Z, depending on where you're from, and that stands for zusammen, I guess, which is a German for together. And I got out of a book by McMurtry that you can remember that by saying in a funny accent, "the same side of the double bond." So that might help you to remember that they're on the same side. If they are opposite, it's designated E for, I don't know how to pronounce that, entgegen, or opposite. You don't need a funny accent there, but they both, E and enemy, both start with the same letter. So you might just remember that means they're on opposite sides. So what I'd like you to do is stop the video now and just go through the examples and see if you can name them. And then we'll come back to that. Okay? Okay, so hopefully you're back. Let's go with the butene for now. So remember, when we draw these things, we tend to draw them at 120 degree angles. And so we would have that, and we would have this, and so if we sort of put our plane here, we would look at this. This has got a mass of 15, a mass of 1, a mass of 15, a mass of 1. So this is the higher of these two, and this is the higher of these two. They're on the same side. So this would be our Z conformer, and this would be our E. Okay. Let's go back to this one. Draw isomers of 2,3-dichlorobutene. So again, let's just draw the double bond. And where are we here? So we're going to have a CH3. And we've got a chlorine on the 2, and we've got CH3, and we've got chlorine on the 3, so we could have that one, or we could have this. And once again, like if we look at this, this has got a mass of 35, quite a bit bigger than this. So this would be my higher one. This would be my lower, my higher. And so this, again, because they're on the same side, would be the Z, and this would be the E. Okay, so that's very simply how you do that. I've challenged you there in case of a tie in ranking. What do you think the next sequence rule would be? I don't think the IB needs you to go beyond that. I think they'll stick to very simple examples of this. This is a fairly advanced, I don't think I even took this when I was in university, but that was in another millennium. Anyway, that's all for now. There's some homework there for you that you can do out of the notes and for next day, and I'll see you later.